All right, cool, welcome. I'm Tim Mecklem. I am the VP of Engineering and Delivery here at Launch Scout. And like I mentioned at the very beginning, I just gave a conference talk about how to design real-time web applications. And design in this sense is not necessarily like the UI, and hopefully you'll notice that as we kind of go through some of the examples. It's not about just how it looks, which design is never about just how it looks, but it's about how to structure applications and how to think. It's a kind of a paradigm shift for building things that are able to be updated based off of events that are not coming from a request from the browser. And I'll kind of go through that. I'm going to kind of fly through the slides from the talk a little bit just to get the context in place. And then we're going to hack on some code. And I truly mean hack on some code because I've already been doing some of that this morning. Yeah, and Super Chris is here. And maybe at the end, he's just brought pizza for the people in here. So I don't know, we don't have like smell-o-vision, but it smells pretty good if you're remote. Maybe order some pizza for yourself later. All right, so one of the questions that you can pose is, do the web applications that we're building today support real-time decision-making better than the technology that they replaced? And if you kind of step back and look at some of the technologies that were around before the web, we had desktop applications that connected to on-premise databases. Those are like rich client Windows applications, that kind of thing. We had green screen apps, right? We had terminals, dumb terminals connected up to mainframes. Sometimes those things would update right in front of the user that was using them. And that kind of interaction, I think we kind of lost when we stepped into HTTP and HTML, right? It was never actually supposed to be what we've made it, which is probably true of most things with technology. But HTML and HTTP were supposed to be document delivery mechanisms, right? And so if you kind of think about it, it's this staccato request and response kind of mechanism where the browser is always initiating an action and the server is sending something back. And along the way, we thought, hey, let's get clever and let's build like CGI scripts or different iterations on top of that. That resulted in us being able to deliver dynamic content to the browser that let it reflect new information that the server knew that wasn't just files that were stored on the disk. So that's cool. But it's all based around this kind of static view of the world. But we kind of know differently, right? We know that information is not static. Everything changes underneath constantly, right? We've got inventory changes. There's like forum users are posting things, emoji reactions flying all over the place, election results being tabulated and reported in real time. Yeah, and like for my flight into Atlanta for the conference that I just spoke at, I had the American app loaded up because my flight was delayed by like several hours on both legs. And I kept having to pull down. You can kind of see at the top of that. I had to keep pulling down the screen to refresh it because I would look up at the screen on the wall, and it had a different time for departure than my app did. And I was getting frustrated by that because the information was changing out from underneath me live, and I wasn't getting a new version of it. So data is always moving. But what's interesting is I think we're entering a place in time where users of web applications are expecting the data that's in front of them to be always fresh. Maybe not for everything, but it's increasing that we get feature requests or we get expectations from users that when they're looking at a page, they're actually seeing updated information and it's not just a static view or snapshot of the data. So it's kind of cool because we have a good problem. The exciting news is that the technology that we have available to us right now is capable of solving these problems. And people are expecting these things, but what's actually kind of interesting is that we're struggling, I think as an industry, we're struggling to apply the technology that we have to improve to improve the experience of users. So I think sometimes it has to do with just kind of the tools and tech stacks that we're stuck in maybe sometimes, or that we're not embracing newer technologies. And sometimes I think we actually fail to look at the problem from the user's perspective. There's a couple of different reasons I think that we get kind of stuck delivering a solution that may not match expectations. But really I think what our underlying difficulty is that there's a paradigm shift that's happened and we're in some cases reeling to catch up to it as an industry. So just for the purposes of what we're talking about, I'm using the phrase conversation capable to describe what it is that I'm thinking about. And what I mean by that is it's a technology that has first-class support for a bidirectional conversation between the information and the user. Not just things that are browser initiated, not just request initiated updates to the screen, but when something happens that was initiated by some other part of the system, either another user or a back-end process or an IoT device deployed somewhere, getting that information in front of the right people in a way that they can use it in a relevant way to make a better decision. So I'm going to skip most of this stuff because it's just talking about me. But I guess the one takeaway from this, other than maybe playing around with a little bit more Ruby code, is to think about the problems that you're solving that require a real-time aspect to them, and think about it from an end-to-end perspective. It's not, it's easy to say, well, the experience that the user is experiencing is a front-end team concern. Or, those events that are flying through the system and need to be updated at the right times, that's a back-end team thing, right? They're the ones that know all the event infrastructure and architecture and everything. The problem is I don't think you can actually deliver a good real-time experience unless that team is working together really well, meaning the back-end developers, the front-end developers, the front-end designers, and the back-end architects. Everybody's kind of got to be working from the same playbook in order for that stuff to work. So that's kind of maybe the takeaway, is that if you're struggling to do this stuff, but you do have a technology that supports it, it might not be the technology. So I want to kind of demonstrate a couple of problems just to kind of get our heads wrapped around it. One of these is the one that I tried to emulate in Rails, and we're going to have a lot of fun trying to make that actually get all the way across the finish line. But there's a couple of things where you might need to consider real-time features or functionality in your application in order to support the user's experience well. One of those is in the problem of scarce resources, to borrow from an economics term. Commerce is an easy one for this, right? Because a lot of times what we're doing when we're selling things on a commerce site is we're actually modeling digitally something that has a physical manifestation, right? We're trying to sell a physical product through a digital representation of it. Man, I wish I had grabbed some screenshots from the whole Ticketmaster debacle for Taylor Swift stuff, because there's like a fury on the internet right now, because what they're trying to do is Ticketmaster's trying to sell a scarce resource, right? They're trying to sell the experience for the concert of a particular location, one seat during that concert. And so they're having all kinds of problems because the resource is so scarce and there's so many people that are interested in it, and other reasons I'm sure that people have philosophically about Ticketmaster. But so I want to kind of think about the commerce problem as a specific thing for us to focus on today. So let's just kind of think about what happens when you don't have a real-time experience. And we'll kind of play a little game here, right? So this is a live demo, a live slide. And if you can imagine, these are two different people's browsers, right? I'm going to be Tim on the left. Hopefully that makes some sense to you. Katie is actually the person who co-presented this talk with me at one of the conferences and helped me to flesh out some of the UX concerns with it. So Katie's also in here. And we both want a scarce scarf. I picked words that are really hard to say together like 5 times. But we both really want a scarce scarf. And there's one of them, but there's 2 of us, right? And so kind of what you might imagine would happen here is we go in, and I try to add it, and I've added it to my cart. Everything's great. Katie comes in, and she adds it to her cart, right? So one of us is going to be faster to the draw here. And because we didn't build a real-time system, neither of us know that we're fighting over the same thing, right? If you can imagine somebody in like a grocery store, we'd be like coming to blows over this thing. Maybe that's happening for Taylor Swift tickets somewhere. But we both have this thing in our cart, but it's the digital representation, 2 different digital representations of the same physical thing, right? So Katie's a little faster with the credit card, so Katie won, right? What's going to happen when I click checkout? Somebody just throw out an idea. What are some possibilities of what's going to happen right now? 500 server error. All right, what else?
It tells me that I successfully checked out and it's lying, and I get to figure out about that some other time.
All right, so here's another idea. We don't actually know that we've sold 2 of the same physical thing at this point, and maybe it lets both of us check out, and then we've got to figure out what to do with that. Any other ideas? Any other possibilities? Somewhere in the middle of a 500 immediately and letting somebody check out.
You get an empty cart, saying there's nothing in your cart, maybe?
Okay. All right, let's try it. I think we click checkout, we get kind of that middle ground, right? Uh-oh, we're out of this product, we can't check out. And that's cool, because at least we didn't make an inventory management customer service problem. It is a customer service problem, but it isn't like an after the fact somebody's got to get disappointed because they thought they actually went through and purchased it. So let's kind of talk about some problems. From our business's perspective, assuming that we're running a business here with this, we've just soft committed inventory that we don't have. If we don't catch it at the point where we did, then all of a sudden the fulfillment center and the customer service, like all these other areas within the business are now having a bad day. They have to disappoint somebody and either email them or call them or something like that. And we left the user to dead end. There wasn't anything they could do. They could maybe remove it from the cart and go shop somewhere else, and maybe we lost the customer, but like you can't really do much with that. So it's not great. Those are problems. They're kind of tactical problems, though. There are problems from a business perspective. The real issue, if we step back and look at it, is that we actually took our business problem and we put it onto them and made it their problem, which is a kind of a bad UX, just a bad UX decision altogether. Think about Tim here. He might have had some really strong sentimental attachment to that scarce scarf, right? Now he's got nothing he can do about it. He doesn't have any options. He could go somewhere else to buy it. Maybe, I don't know, it's scarce, who knows? So we prevented a problem in the way that we implement it, which is we didn't let two people actually buy the same physical thing, but we still allowed a problem to seep out from our abstraction, right? Our abstraction is that we have a cart in this commerce example, but that's not the thing, which is the thing we actually are trying to sell, the physical product. So we've pushed a leaky abstraction problem out onto the user's experience, and that's not great. So what are some things that you can do about this, right? Obviously, if you know that somebody has put something in their cart and you're trying to model that abstraction somewhat realistically, you can try to just picture in your head, what if you were actually strolling down the aisle with a physical cart and you pull a physical product off the shelf and put it in your cart? Is somebody else going to take that thing and put it into their cart also? Not unless you see them doing it, and that's where you get to fight with them, right? So if we have that in mind and we're trying to really actually model this problem well, we need something more than a request response driven thing, because there's no way for somebody to get an update when they don't know that the update has happened, right? The best they can do is mash the refresh button, or we can put timers in or something like that, right? So thinking about this a little bit differently, we've got the same kind of scenario. We've got Parker and Andrew, and in this case, they're both wanting the same rare raincoat. Maybe it's more like a coat right now. It's kind of cold outside. But we also still only have one of those things in stock. If we're trying to do this in a way that helps them have some agency in the decision-making process, then we need something better, right? So we need to be able to say, when somebody adds something to a cart, a couple things might happen, right? We would kick the other person out of being able to add that to the cart, right? Somebody physically took the thing in front of them. Maybe they were 2 steps away, but they were still second in line for one thing. So they can't add that thing to their cart anymore. But because we know it's a scarce resource, we might actually tell the person who did win in that scenario, you've got a limited amount of time here, which also models reality, right? You can't walk around, well, you can walk around a store with something in your cart for a long time, but if that store closed down for the night, you have to either buy the thing or somebody's going to put that back on the shelf, right? So you have a limited amount of time in order to check the thing out. That's something you see with a lot of Eventbrite kind of things, where if you add the thing to your cart, you don't have forever to do that. You have a claim on the resource, but it's really like a token to be able to buy the thing, not the thing itself, until you actually check out. Let's say you also have maybe some inventory management going on in the background, right? Somebody in the fulfillment center just received more of that product, so it's not as scarce as it once was, right? If they bring in another item, you can actually make everybody's day nice, right? You can allow everybody to buy that thing, but only if you know that it happened. And that's kind of the trick here, is that the web wasn't really built around this concept originally. So I think there's an underlying principle here, which is we want to, as software developers and as designers and as product managers and all the people along, I guess, the value stream, if you want to call it that, we all want to value and respect the user's agency, right? If we can get the right information in their hands, they're going to make the right decision, or at least they'll be empowered to be able to feel like they're in control of the situation as much as is possible. But when we don't give them information real time, when we don't give them information that's relevant, at the right time, they don't have the ability to make the best decision for themselves. There's some other examples. One of them that I thought was kind of fun would be like build a little Twitter thing, and there's a little bit too much data coming in, right? Potentially this is something you could read, but as people in your friend group start posting more and more and more information, it starts to get a little bit overwhelming. So there's a bunch of different scenarios where you need to be able to build real-time systems that help the user to make relevant decisions. I just kind of had to put an 11 on this. I had to make it go to 11, so in case you're wondering what that's about. That was just from the conference. But we're not going to use this example. We're going to go back to the commerce example and kind of work through that. It might be a good opportunity now for us to just kind of talk about some of the other things that you might run into. And then let's go right into the Ruby code. So there's a few things that you might also encounter that might make you think, I really need to build a real-time feature here. One would be seamless session handoff between devices. If you go back to the commerce example, if somebody's browsing on their phone and they see something that they think they want to get, but they want to do a little bit more research, they might actually add that thing to their cart, and then they'll want to go over to their desktop and make sure that that thing is still there so that they can do some research on it and stuff like that. So sometimes you want that session handoff to be there. Sometimes you don't. Like if you have a specific filter that's being applied on one tab of your browser, you might not necessarily want to apply the same filter on another tab. One of my use cases for that is I have a list of transactions on the left, a list of transactions on the right. I'm trying to resolve consistently the things on the right, so I'll filter the stuff on the left to see what past transactions like that look like. But the particular app I'm thinking of actually applies the filter in both directions and gives me like a really bizarro experience. So you kind of have to think about what things do you want to sync across sessions and what things do you not want to. Collaborative editing and drawing, that's one. Handling disconnects gracefully, that's really important. If you start to build an application that has real-time behaviors in it, you also have to tell the person when they're not getting that experience. And I'll mention one more thing right before we get to the code that is important to think about with that. Notifications across multiple connected devices. I don't know how many of you have seen the Slack, when do we and how do we send a notification flow sheet thing, like a decision tree or whatever. That thing's massive and very complicated. Notifications are really tricky. If you have the ability to push information to the user, how to do that effectively and push it to the right devices so they make a good decision without spamming them and getting yourself essentially uninstalled from their phone or whatever. That's kind of tricky, but you need technology to support that. Dynamic maps and location-based services are great. If you can give people a picture, whether it be a map or any other visual representation, it's a lot easier to consume information that updates in real time that way. Paging data is a really interesting one because it feels like that's one of the things that as an industry we believed that we had solved for a long time. And most paging works with windows, right? Sliding windows of I've got this offset and I have this amount of results, this number of results that come back. But all of that was kind of built on the assumption that the data underlying it really never changed, right? So if you're clicking from page 1 to page 2 and that paging is based off of a query where the table data underneath the query can change and interleave and remove or add records, then you end up in a really interesting situation where you'll have gaps or you'll have overlap and people start to like look at that table of information and freak out a little bit. Like they start to wonder if you actually know what you're doing. So there's other things you can do. That one in particular, you can use a last seen timestamp based thing. So if there's new information coming in, you can use a timestamp rather than a specific offset based off of like a record ID or something like that. That will at least allow you to see new information as it comes in, but it's still a pretty challenging problem to conquer. But you can't, like if you're building a real-time app, you can't assume that all the data underneath one of your tables that you're paging through is static at that point. Otherwise you start delivering a weird hybrid real-time, not real-time experience. And then I kind of mentioned it with the fulfillment side of things, but like integrating IoT and other non-web events needs to use an infrastructure, an event infrastructure that's similar to the event infrastructure that you use for browser clicks from your users. The more that you can make events within your system seem coherent or consistent with each other, whether it be somebody clicking on the front end or somebody else going and grabbing another product from a fulfillment center and clicking a button in the back end or a physical device or something like that. The more you can make those events appear and behave and be handled similarly, the better the experience that you can build. And that requires that requires a lot of coordination across the end-to-end product, right? Because you have people using the front end, and you've got your front end team, they're firing off events. You got the back end team handling events and also pushing other kinds. That one's kind of tricky. So just kind of stuff to think about if you're building applications that have some real-time stuff in them. Yeah, so all the examples that I did in here were in Elixir and Phoenix, and so trying to adapt them to Rails is where it got a little bit tricky, so that should be kind of fun. But there's a bunch of different technologies you can use in different stacks. Elixir, Phoenix, LiveView, they all have, LiveView is kind of it's the real-time capable, conversation-capable mechanism within Phoenix that I think is the most popular, that allows you to push events very easily via like a pub sub, and then everything in the browser can just update. You don't have to think about re-rendering things or anything like that. You just update the state in the right places and the right processes, and the browser gets the benefit of all that. We're going to talk a little bit about Ruby Rails and Hotwire, also channels. There's also PHP, Laravel, Livewire, Next.js, and server-side rendered React, .NET, and Blazor. They're not all exactly the same thing, right? They're not all trying to solve this problem, but they are enablers for certain parts of the technology. So if you're looking for ways of doing this in other stacks, those are good ways to go. So one thing to note, I guess I kind of mentioned this about team structure. This is an important thing. If you have read up on or have heard about Conway's Law, I think that applies really aptly to this situation. Because if you have teams, and Conway's Law is that if you have, whatever you build as a product is a reflection of what your team's communication structure looks like, right? So if we apply that to what we're talking about, if you've got teams that are very isolated and disconnected from each other, it's going to be really, really challenging for you to build a cohesive real-time kind of an experience for people, right? If your backend team has a very, very strict contract with your front-end team, and they don't, the two teams don't communicate that well together, you're going to have a product where you have a very different connection between your backend and your front-end, and it gets a lot harder to push events and handle messaging and things between those things. So I guess if there's anything that you think about in terms of the end-to-end takeaway from that, it has a lot more to do about how your team's processes and structures work, less about the technology, except that if you pick poor technologies for it, it just exacerbates that problem of being isolated from each other, right? If your teams are working in completely different languages all across the board, it will necessarily be harder for things to transition between those systems in order to give like a rich, event-driven kind of environment. And there's lots of solutions to that problem. One of them is to limit the number of languages that you have to use across the board, and to limit your teams from being too big and letting them work in a cross-functional way. So that's just kind of like a little takeaway. If you're not thinking about the technology side of it and you're thinking more about team structure, compose the teams in a way that allows them to take advantage of their disciplines really well, but that they work really closely together. All right, so the last thing I want to mention is you've probably all got good examples in your head of this, but there's something that I'm calling the real-time uncanny valley. And I just want to like demonstrate what that looks like a little bit through one picture, and I'm wondering if anybody recognizes this page. How many of you seen this page? Yeah. How many of you have gotten stuck on this page? It's probably just me. All right, so what happens is you build a repository in Git, you get really excited about your new thing, and then you get ready to start building it. So you commit something, and it's a beautiful commit message, right? Rails new, and then all the great things like disabling all the things you hate, enabling extra all the things that you really like. You can make that perfect first commit message, and you go to push to GitHub. And then you follow the instructions like you're supposed to. And then you look at this page, and if you're anything like me, you're like, what happened? What did I do wrong? It's because this page is static, right? I mean, it's dynamically rendered, but it's a dead tree render of this page. But I've done activity that should have pushed an event to change this page, because everything else about GitHub is real time, right? You push up a PR, you start getting comments. Those things generally show up in your browser without you having to do anything. CI update statuses, like you get little things popping in. This page is not like any of that. So you have to refresh this page to get past it. And that's what I'm talking about when I talk about the uncanny valley. This is like the one non-player character in the game that's just like walking into a wall constantly, and you're like, Everything else, everything about this environment makes sense to me. I'm interacting as if it's real, but there's this one person that just keeps like they're ruining the experience. They've got that 1,000-yard stare, and it kind of causes you to reject the application, right? In a way that you stop trusting it. And I guess that's the thing that I want to point out is if you start building real-time features, make sure that you make the contract with users really well scoped, right? If you're on a page that does real-time in an app that mostly doesn't, make sure that you indicate to the user, this is a real-time page and here's the contract. Maybe it updates every 10 seconds or something like that. But make it clear when you're building these things, especially when you're in a transition between something that's not and something that is a real-time app, if people lose the trust in your application's real-time features, they will revert to just mashing the refresh button everywhere, right? If they feel like they need more information or better information or newer information, they'll just refresh the page. That's cool, but the problem is if you do that and you've built them real-time features and they start to trust a little bit about those things, as soon as they reject something that doesn't look right to them, they'll start actually treating your app as even less trustworthy than if it was just a response rendered one-time kind of an app. So that's something to be aware of. Stay in the uncanny valley as short of an amount of time as possible, or at least make it clear what the contract is if you're building a real-time feature, because that's really important. All right, so that's it for the presentation side. If we go back to the commerce example, oh boy, I have a lot of slides. Yeah, if we go back to the commerce example, oh, funny, I have a different snapshot on my speakers notes than I do up here. I wanted to try to model this in Rails and build the sort of the dead render version of it and then think through what it looks like in Rails to build something that's more real time. And as a caveat, I didn't finish this. It's not 100% complete, so we might have to work on this a little bit. There might be a little bit of follow-up on it. The other interesting thing that I found out as I was working on it is that I thought that nobody else was actually doing the thing that I'm doing. And it turns out in the last couple of months, there's been quite a bit of activity, especially from hey.com and from the Basecamp people. So I'll kind of try to touch on that a little bit if we have time. But the idea that we want to do here is to take this application that is a request render response style mechanism and turn it into something that is aware of information that's happening and that's event driven in real time. So let's kind of get to that. Are there any questions about anything that I presented on? I don't want to go too late today, but I do want to give opportunity for people to ask any questions. Nope. Cool. All right. So let's get out of presentation mode and into the code. Into code mode? Is that a thing? Yeah. All right. So I lovingly called this Rails application HotSocket, which is kind of like Hot Pocket, but it's kind of a mashup of Hotwire and WebSockets. We did this at a Ruby Brigade in the past, and we actually got pretty far with it, and then I lost all of that, and then they changed everything on me. So hopefully you'll see where I get stuck, and somebody will be able to help me with some pointers here. But this is kind of the experience that we're looking at. Let me get it a little side by side here. All right. So we've got Tim, and then we've got other Tim. And other Tim's kind of a jerk. I don't like him very much, but he's here too. And so we have two people looking at the same product in the cart. And we've got the same problem, right? So this is in the Rails application. It's what I did was just generate a new Rails application. I added devise because I like pain. And then I added a couple of scaffolding things and dropped the same styles in from the other example. So there's not a whole lot to this Rails application, especially tests. There's none of those. We would normally write those, but I got a little bit behind the ball here. So let's kind of work through the same example. All right, I'm going to add that product to the cart. Similarly to the other example, it's in my cart now. I have it. I can remove it probably, and I can go back to the product page and see that it's there, right? And if I add it to the cart, you'll notice on the other side nothing happens, right? But if I were to be on the other side and refresh, hey, look, I just noticed that my inventory dropped. So I can't click that. So if I remove it from my cart, you can see that it re-incremented the product inventory in a very super naive way. And now we have it back in stock for one person. So that's kind of the problem that we're trying to fix, which is when one person adds this thing to the cart, the other person can see immediately this thing has gone out of stock. And the way that I want to solve that problem is through WebSockets and Rails channels specifically on the server side to be able to push through that WebSocket, and then to actually push partial rendered turbo streams, which I'll kind of explain in a minute, assuming that people haven't heard of all of this stuff yet, to the client and have that turbo stream update the right frame on the page. So there's some terminology to get down really quick. First, I just kind of want to see, like a show of hands, how many people have worked with application or action cable and channels in Rails? Or WebSockets in whatever framework that you're using, whether that be directly or not directly. How about remote? Like a show, like a thumbs up if you've worked on channels and WebSockets, a thumbs down if you haven't. Thanks, Steve. Okay, really interesting. Okay, so that probably answers my other question, which is how many people have actually worked with either Hotwire as an umbrella across the things that are working in Rails, or specifically the turbo features within Hotwire? Not old turbo, what was it called? Turbo links. Not turbo links, but turbo, meaning turbo frames, turbo streams, and turbo drive. How many people have worked with that? Thumbs up, thumbs down. All right, Steve, I see the Hotwire experience from Steve. Might need to use some of that today. All right, so there's the way that channels works is you can establish a WebSocket connection from the browser and have the server either broadcast information or send you new information over that WebSocket channel. So that's one of the ways in which we can achieve real time, is that it starts a conversation with the server, that the server can initiate a response or can initiate a message without having to be told first, hey, can you tell me what new information there is, right? It gets rid of the request response cycle part of that. The other part of this is Hotwire, which is called HTML over the wire. It's kind of an acronym for it. It's composed of a number of different things. Let me pull it up. Hotwire.dev, I think, is how you get there. Oh, it's hotwired. Okay. Ooh, that's nice. I like that. So it's composed of a number of different technologies, one of which is Turbo. And that's, if you look at it the way that it was originally designed, it's for like speeding up page changes and form submissions. That's the part of Turbo that I burn with fire as soon as I see it. I hate that. That's just me. And if I encounter it in a project, I can use it if I have to. But I do. That's the kind of Turbo links behavior that I always used to disable immediately whenever I generate a new Rails app. What's really interesting is this idea of streaming partial page updates over WebSocket. That's really exciting to me. And the other part of that that's somewhat exciting to me is the next sentence, which is without writing JavaScript. So that's cool. There's also Strata, which is like a way to do mobile app development that's native. I don't see it. They used to put Stimulus. Oh, here it is. Okay, that's weird. It didn't show up, or maybe I just missed it. There's also Stimulus, which is a JavaScript framework that kind of feels and looks a little bit like the controller mechanisms within Rails. Stimulus is fine. It's useful when you need to like add some browser native kind of examples. Strata wasn't even like ready for us when I was looking at this the first time. But Turbo, specifically Turbo frames and Turbo streams, are the thing that I want to focus on. So if you want to think about what a Turbo frame is, let me switch my branch here. So this is the dead render version of this page. And if I check out, I'll push all this code up right after this, especially if I can't get it working. I might need some help. So I'll check out the sockets version of the app and start it up. Can you all see this okay? I don't know how much we'll be doing in the command line, but. And then I'll bring up my editor. And we'll just look at a little bit of the code to start with. Yeah. Hang on, there's like a big mode. Space TV. Oh. Big mode. Thanks, Emacs. Okay. So let's go look at the controller first for the products. So the products is a really dumb model in the sense that inventory is actually right there on the product. So when you're looking at that page that says, hey, I'd like to look at the scarce scarf and buy that, there's no like complicated model going on there. Okay, so let's just kind of look. So show is just going to grab the product and then render essentially the show HTML. And tell me if I'm moving too close. I think most of this stuff, if you've seen any kind of MVC framework, but especially if you've seen Rails code, it shouldn't look all that weird. Oh, ignore those inline styles or the styles at the top anyway. Yeah, okay, so we've got, this is the cart. I didn't mean to show the cart. Products. Okay, so it should look fairly straightforward. We've got a view cart link, and then we have something called a turbo frame tag, which I'll talk about in a second, and then we just render a partial for the product, and then there's some gross JavaScript at the bottom that does some things that we'll talk about too. So the turbo frame tag is really interesting. What that does, I believe it's a custom JavaScript component, custom web component, if I remember right. But all it does is render a turbo dash frame HTML markup. And what that does is allow you to target a specific part of the page for a turbo update. So basically what we're doing is we're drawing a container around the partial for the product that allows us to replace or append or delete any of the content inside of that turbo frame tag whenever we get new information in. So a frame tag is basically a way of saying, this is a window of the screen that I want to be able to update. It could be the whole screen, it could be a little piece of it. In this case, it's just the product part. So if we go back and look at the browser, that's just this part right here, right? And we can go look at the HTML. It's kind of hard to see. Can I font bump down here? Sure can. All right. I think I need to reload it. And we'll see the turbo frame. Here it is. So there's our turbo frame. And then inside that is just what got rendered by the partial. That make sense? Cool. So that's half of the problem is the turbo frame. The other half of it is called turbo streams. And if you go look at turbo streams in the documentation, they are kind of interesting. Let me see if I could find, here's the handbook, here's the reference. All right. So turbo streams give you the ability to, they're basically like CRUD action commands wrapping HTML. So you can have a bunch of different kinds of actions. Oh, I thought there was more here. Okay, so you can append to a frame, right? The target is the turbo frame that you're targeting. So you can append to that and basically take the last thing that's inside that frame and append to it. You can prepend, throw something at the beginning, you can replace. So this is if you have like a list of things going on, you can basically update a list by inserting things into the list in different places. Update will take the inner HTML basically and replace it with whatever the turbo stream command has. And then there is a remove action, which will just remove that turbo frame altogether. There's a before, which prepends a child. After will append something after the frame, if I remember correctly. And then you can do multiple things. So you can basically, if you have a list of things that you want to do in the browser and have that handled automatically by Turbo on the JavaScript side, you can basically just send it a series of turbo stream events, and they will replace things in the turbo frames that you've specified, right? So if you want to think about what we might want to do here is if we're looking here and we've got this turbo frame, if I in the back end understand that an event has changed that changed the inventory, I can publish that event over the channel, send a partial of the new product information over that channel, over that socket, handle that in the JavaScript, and then basically update the screen. So what I thought was really novel about the approach that we were looking at is that DHH in one of his Twitter posts at one point made a really weird side comment to a conversation that was in process. And what he said was, if you're using turbo frames and you're using turbo streams, all that you have to do to process a command in a turbo stream is just append it somewhere in the DOM. Like drop it in the DOM somewhere, which is crazy, right? So like the idea behind that would be if you have a series of these turbo stream kinds of things and you just basically throw them onto the document at the end of it, Turbo will pick those things up before they render and actually process them as actions, and it works, which is crazy. And that was the thing that I'm trying to get working here. One thing to maybe note, though, is that in the time since I've done this, and we did this as like a, gosh, there's no way that actually works that way, is it? And it did. In the time since we did that at one of the Ruby Brigades, maybe, I don't know, 6 or 8 months ago, they have now added in the ability to stream to, like, to do turbo streams from even like model callbacks, like model hooks, so that if something were to change the inventory on the product, you could do a turbo stream of the product to all connected things, and it just kind of renders the partial for that thing correctly and updates stuff in the HTML. I haven't done enough research to really understand how that works. That's really interesting. I think I don't like the abstraction of doing it from the model. I think that feels really weird. But at the same time, they're starting to think about doing these and building in some native functionality that we were hacking in earlier with the Ruby Brigade. So I'm kind of thinking through. I might link to, after we're done, might link in the Discord server the things that I found in the meantime that were basically like, here's how to do the thing that Tim is failing and struggling to do right now, but it's as a first-class citizen within your Rails app. So adding this in is essentially just making sure that you have action cable in and configured. It usually takes like Redis or something like that. And making sure that you have turbo in your application, which if you're like me, you probably ripped it out as like the first thing that you did a long time ago. So adding that back in isn't really hard, but it's not, it's not going to be there by default for a lot of people. So let's kind of go back to the code and talk about that for a minute. All right. So we've got the turbo frame tag, we've got the partial render. That's sort of just like if you're thinking about server-side rendered React or something like that, this is the thing that will give you SEO, right? Like if Google comes and crawls this page, it'll have already rendered the partial for the product, and it'll be able to crawl all that. But the turbo frame tag makes that a dynamically updatable part of the screen. So if we go look at the channel part of this, that might be where things get a little bit more interesting. We'll have a product channel. And this is where I'm actually having the most trouble, so ignore some of the gross stuff. But channels are interesting because when you subscribe from the client side, you can pass parameters in. And one thing that you could do is if you're looking at a particular product page, you could say, hey, I care about seeing updates that happen to this product if there's anything that's going on that's real time. So there is a client and there's a server side related to this. So let's go look at kind of both of them together because they're easier to see that way. All right, so you kind of remember maybe that like weird JavaScript that I had at the bottom. I'm using a global essentially to handle the product SKU thing. So basically what I'm doing is setting something on the window for the product SKU. And if that thing is set, then I know that I'm looking at a product page and I can go ahead and create the channel and connect. There's better ways of doing that, but this is, if nothing else, a really fun, hacky way to do things. And we're connecting up to the product channel and we're passing up a product SKU that represents the product that we're looking at. When it works, you'll see a little console log, and that's really all it takes, right? So that subscriptions create will subscribe to here, and basically all you have to do in the subscribed part is say the channel name that somebody cares about. So in this case, we're going to call our channel product dash and then the product SKU that they're looking at. And that's how you subscribe to specific updates from that channel. Once the browser's up and running, you should be able to see the little console log that we had, which is connected for comfy sweater, right? So we're looking for updates for the product comfy sweater. That's neat. The other thing that you have to do if you're a JavaScript side of that WebSocket of that channel connection is you have to say what happens if the server sends me a message. And that's what the received callback does. So you define a function that's called received, and it takes in some kind of a payload. And what you want to do is you want to handle that payload in some way. And this is kind of where I got stuck. On the server side, if something happens that changes the inventory of that product, the expectation is that we'll call product channel.inventory change for that product. It's not so much a pub sub as it is like I'm going to call this direct method. There's other ways to do that as well if you get into more of a pub sub style of things. But that's kind of trying to keep it mostly simple. So if we go look at the controller for product, we'll see, nope, sorry, the cart. The cart is where things get claimed, right? So I shoved it all together, right? If you add something to the cart, we're going to look up the product that you're trying to add. We're going to try to decrement the product inventory, add it to the cart, and then we're going to say, hey, as a side effect, go tell everybody who's looking at this product that the inventory has changed, right? And that's what would trigger this. So where I got a little bit stuck is basically what we want to do is take that inventory changed event and the new product information. We want to create a turbo stream command from that, send that over the WebSocket, and then on this side, we'll receive that payload, and then basically append an element to the page that represents that turbo stream, and then it'll just get handled for us. But this is the part that they've kind of changed a little bit on me, I think. Maybe I just misunderstood it the first time around. But this isn't working exactly the right way. So let's just kind of go look at where I got stuck and see. But you'll at least be able to see the event-driven part of this. So we've got two people, and they're both looking at the product version of this with the turbo frame tags. So if I open up the WebSocket connection on here, and you can usually do that by going to the network tab and then go into the cable if you're using Rails. So you can kind of see the messages that go back and forth between the client and the server. That's pretty typical for WebSockets on all the things. If you use Phoenix, they look a little bit different and they're harder to understand if you're using LiveView, but they all still log here as messages. And so right now it's just pinging to keep that thing alive. Now if I, over on this side, click Add to Cart, you can kind of see there was an event that popped up at the bottom here, right? So this is as far as I've gotten with this, which is it has now updated the channel, the product channel, with the particular product SKU that we have, and the message that we sent was a payload that has been logged to the console, and this is our turbo stream, and I think I got that wrong. So there's a couple things here that I want to update and kind of send out after this is over, but this is basically the idea, right? We've taken an event in that happened because somebody in the other browser side of things clicked it. It sent out an update action over the over the WebSocket with a turbo stream, and we're just trying to append that to the body. And that should update the partial rendered part in the middle of that and say, there's none in stock, and this thing turns into an out of stock button. And you can see the HTML that's gonna get created, right? It's gonna say comfy sweater, uh-oh, there's 0 in stock. You get a button, but it's disabled and says out of stock. So that's kind of the idea of how to build an event-driven feedback system where somebody else can trigger an action that updates that browser. It's 1 o'clock. And I was thinking that maybe I would play around with this with whoever wants to hang out for a little bit and see if we can get it working. But that's kind of the demo part of it. If you're trying to add in real-time capability to Rails, I think the way to go right now is to use Turbo, basically to pull in the Hotwire feature that you want, but probably that means Turbo frames and Turbo streams, and also Action Cable. And once you do that, you can end up with something. There's like a turbo channel. Turbo Chanel, that might not be the same thing. Yeah, so there's actually an example or 3, including one on the hotrails.dev website, which I'm not sure if that's an official site or not, but this is a thing that I ran across as we were doing it. You can basically do this broadcast thing based off of updates that happen, and all that you really have to do to make that work is, there's a couple things that they kind of walk you through. I thought that was, maybe it's a different one. I'll link all the things that I ran into, but you can basically say, I want to be able to stream changes for this model or for this piece of thing, and it creates a specific channel that does kind of what we were already doing, like handles the turbo stream updates automatically, so you don't have to write any of the JavaScript for that, but it also connects that up correctly and streams from the correct object. If you know the channel terminology, it basically hooks all the pieces up so that when the thing happens on the server and you just say, hey, whenever this thing happens on the server, make sure everybody who's looking at it has identified the change. It just makes that work. So that's probably for a future meetup to really play with and see how they've done it. But I think hey.com is actually the people who are pushing this forward. I saw some of the posts that kind of referenced hey.com features, and so it looks like they went down the same path that we did a few months ago in building out their real-time features and making sure that people get updates in the email client, web client that they're building. So it's pretty cool. It's neat to see that other communities are doing this and other companies are thinking about this, because I think this could be really powerful for Rails if you're trying to build rich, but not just rich and interactive, but rich, interactive, real-time applications with Rails. And you don't really even need to use, for most of this stuff, you don't really need to use JavaScript. So you can keep the front-end discipline for the really interesting and exciting things like map integrations and 3-dimensional renderings of Catan boards and things like that. Yeah, so I don't want to keep dragging on too much longer if you've got to get back to work. Anybody have any questions or comments about it? Is this interesting to you, I guess, is a question that I have. I got some nods in person. Anybody remote who's excited about or interested in this, but hasn't seen this before? Steve? So Steve's been working on one of our internal applications, and when Hotwire first came out, we were like, yes, we're going to use this feature. And we started building it. And Hotwire is, aside from the channel stuff, is still very much a request response asynchronous thing. You can kind of imagine it as basically just replacing the form submits and turning it into an async call that may or may not return turbo streams and update the screen. And it's not all that compelling for that, honestly, for me. We made it work and we've got good features there. But we had to hack around some things because what we're actually trying to build is real-time functionality, or at least more rich functionality that updates more pieces of the screen than what you might anticipate. And just using vanilla Hotwire kinds of features that replace form submits just isn't all that exciting until you start adding in channels and sockets and get more real-time stuff. So I'm excited about this for some of the stuff we're doing on the internal apps and also some of our client projects for that. Anybody else? Joe, I see you turned your camera on. I don't know if that means you want to talk or not.
Yeah, I did have a question. And it's always the fun one to go to, I think, of the scale, and you kind of touched on it a little bit of getting to the pub sub.
Yeah.
I imagine at some point this gets quite noisy with either lots of target sessions or lots of source events and the combination of the two. So
yeah, it can.
Is there guidance on, okay, this works up to this point, but then you need to consider adding in other pieces to keep the system working?
Oh, that's funny. Oh, there we go. Okay. So there's the answer to your question.
Okay.
But that's with a caveat, right? When you're dealing with Rails, you will notice very quickly you have to pull in Redis, right? So you've just DevOps yourself if you haven't been thinking about how to scale it or haven't already had to do asynchronous jobs or something like that. You just pulled in another piece into your infrastructure, which can be tricky, especially if you're doing it in development, everything works great, and then you get 1,000 connected users at the same time. You could have some serious scaling problems that you weren't anticipating. WebSockets, I think, as a result of that, have a kind of a bad name among some people. We were at the Connect Tech conference, and I won't say he shouted me down, but there was somebody at the conference who was very much like, I would never use this. This is terrible. Why wouldn't you just use like an asynchronous call and do a timer or something like that? And I understand that, because coming from the Java side like 15 years ago, maybe it's longer than that now, geez. There was a big problem with having state on the server. There was a big problem with having like big user sessions and having events kind of crash things, and then you end up like taking down nodes, and then you have the thundering herd problem of connecting to other nodes that are still alive. Like there's some serious scale problems there with some of that, and this has a feel like that, right? Like if you get too many people having a constant conversation with the server, you can cause problems. In that sense, it's just kind of a normal scaling problem. One thing that is really interesting is if you're looking at those kinds of problems in that kind of scale, which I know a lot of Rails applications are not, there are alternatives to building things in Ruby and Rails, which is kind of why I built it in Elixir, Phoenix, and LiveView, because when they first came out with WebSockets and channels in Phoenix, they were like, crap, is this going to scale? And so they actually have a blog post of trying to see how many open broadcasted connections, WebSockets, that they can keep going on the same time in one server. And so they kind of got like a little bit of a beefy rack space server, and then they brought online 2 or 3 other beefy rack space servers to generate load. And they got up to 2 million open WebSocket connections with Elixir and Phoenix without having to pull in like Redis or anything like that, and demonstrated that yes, you can do this really efficiently with the right architecture. Which isn't to say you can't do this with Rails. If you generate enough load, though, you're probably going to have more servers running that kind of stuff. So it is something to think about. Another thing that's kind of interesting is if you're on the LiveView side of things, Zach Kaiser, who used to work here, went to work for cars.com, and they rolled out a WebSocket-based real-time LiveView kind of application. So they re-architected all of cars.com and built it on Elixir, Phoenix, and LiveView. And they ran into huge problems, most of which were they weren't prepared for the kinds of observability and telemetry kind of things that they needed to be looking at. And they had some things crash and cause problems for them. So he's given a talk about that. But basically, it kind of boils down to the same kind of ops infrastructure stuff that you're probably thinking of already, which is make sure that your application is instrumented well so that when something goes wrong, you can see what it is and know what the bottlenecks are, and you can scale appropriately. But WebSockets are just another communication mechanism with the server, right? So you can do basically the same kinds of things that you do with request and response. It's just now you're generating a lot more potential payloads, and so you do have to keep your eye on that. You may not want to do this on a big commerce site, right? You may not want to publish out to everybody immediately. You might have to do something that's more of a distributed pub sub kind of thing, or run multiple servers to handle that or something like that. So it will scale. I don't think every technology is well suited for scaling as well as others. So you have to kind of look at that if you're picking a technology for this. Does that answer your question? Cool.
Yep, thank you.
Yep. Anybody else? Cool. Well, thank you for coming. I am going to probably just stay on the Zoom and hack away at some stuff, and you can like poke at my editor and say you did that part wrong, and that would be really helpful for me. But if you are on a time crunch, or you are just kind of done hearing about real time or hearing my voice, feel free to drop. I really appreciate everybody coming today. I also really appreciate everybody who is here in person to help us test out kind of the hybrid experience. Just kind of really quick as a last thing, especially for the remote people, could you give like a thumbs up or something in the middle or a thumbs down based off of like how the experience worked for you? Did you feel well enough engaged, and did everything work well enough for you, or were there parts that you would have improved? Cool. How about in person? Really good? All right. That's really exciting because we've struggled to do that well, just like I think everybody else has. So we're going to keep pushing on it, but I think we'll probably have more things that are like this. All right. Well, thank you, everybody. Appreciate it. What'd you say?
I like seeing you in the corner.
You like seeing me in the corner? Oh, like not like in timeout, but like, okay, I see. Cool. All right, so let's get this thing working. There were a number of different adversities that I encountered with this. One of which is that I could not get it to even do a partial render from the channel. So I'd really like for that to work. All right. You can see how desperate I got. I just started rendering TurboStream text. That's not great. So I kind of want to go back to where I'm at. Alex, maybe you can really help me with this, because I think most of my problems at this point lie in the JavaScript side. All right, so we have our TurboStream action. I'm clearly already missing the template part. And if I could have used the TurboStream.render or TurboStream.update, then it would have done that correctly for me. So here's the code that I really want to write. And then we'll figure out maybe if that's a possibility or not. This is what you would do if you were writing this on a controller. You would say TurboStream.update, and you would update the specific, it would be the frame that you're trying to update, which is product, well, it's that channel name, I believe.
The ID
Oh, no,
number.
What'd you say?
Do you want an ID number? You know, the ID of the element.
Yeah, it's the turbo frame tag ID. So, yeah. So let's go look at that inside of our partial. Nope, not inside the partial. Is it? No.
I'm wondering if it shouldn't be inside the partial.
Yeah, it's wrapping the partial. Okay, so this is our turbo frame tag ID, which just happens to be the same thing as the channel name. I'm inclined to just say channel name, but that's probably not. That'll cause a really weird bug at some point. All right, so let's kind of go look at the TurboStream docs really quick. I'm going to keep calling it hotwire, and it's going to keep replacing it to hotwired. And that's the game we're going to play for the rest of time. All right. Similar to my hesitancy of getting into Elixir, I was very, very resistant to looking at hotwire because of the terrible experience that I've had in the past with TurboLinks, hijacking my app and doing things that are inscrutable. So it took me a while before I was even willing to come to this website, which is probably not great, but all right. One thing that I know I'm missing is this template thing. But if you're trying to, streaming from an HTTP response is really what you're looking for, right? So this would be something you'd find in a Rails controller, and you would say respond to these formats. If the browser is not capable of doing turbo, meaning I guess that would mean that JavaScript is disabled, but I'm not sure other scenarios that might be there. That basically allows you to either do, if it was a turbo stream request, which would have been if the browser, on the browser side, it hijacks the form submit and basically turns that into a window.fetch kind of thing in the background, which then goes via a special header, HTTP header that says that it's, rather than the form URL encoded content type, it turns it into a turbo stream or something like that. And then the controller knows that you're asking for turbo stream and can render that. This is the thing that I want to do though. I want to render a turbo stream message that has an action on a specific thing. And this is how it would look in a controller. So here inside of a channel, I don't get some of those helpers, and I think it probably has to do mostly with just not knowing exactly which things to include as far as mixins go. But I want to render a turbo stream update for that product. There's other ways of calling the actions. Let me see if I can find those. Processing stream elements. Yeah, they've changed a lot of this. This wasn't even here. Like a lot of the documentation about how it even works underneath the covers was just completely missing. That's cool. But it's still, if you look at it, pretty light on details. This is really cool though, this turbo cable stream source element. This allows it to push certain things out via the turbo cable stuff. Let's go look at the source. Or maybe not. It doesn't look like we get to see the source on that one. Oh, here we go. Good. Nope, that's not what I want. This might be the link that I was actually thinking about. Oh, no, just kidding. They're just trying to get you to use hey.com. Yeah, I'm just going to end up back at the same place, right? All right, so if I try to just use that and try to update that, I know that one of the things you can do is basically say what you want to update and then give it a partial of how you want that to render, which would be product. And then I think you also want to pass in locals, but I'm just going to ignore that for the moment and let it give me the error. All right, so let's go back here. I'll jump into the Rails console and trigger the updates that way and just kind of see things that way. It's a little bit easier. So I'm going to look up, I guess maybe just, oh man, I've been in the console lately, huh? I'm going to do like product equals product.first, and then I'm going to call inventory changed. Yeah, so here's the thing that I was running into, which is there is no TurboStream method. And I ended up mixing in the thing that gave me TurboStream, but it was looking for an action view, like base environment. So I was pretty stuck inside, how do I do this when I'm not inside of a controller? And it wasn't clear exactly how to do that. That's what caused me to go back and say, you know what, just for now, I'm going to try to like wrap this thing in a TurboStream action. And I know that I was missing a template, so I'm kind of curious what happens if I do that. I also wonder if it's rendering it as like escaped HTML or something like that. But yeah, let's just do that for the moment. So let me do a reload. I'll call inventory changed. All right, so it's broadcasting to anybody looking at that channel with a payload of TurboStream action update. The target is the frame. There's a template inside there, and then the markup, and then the end of the template, the end of the TurboStream. And so if you were looking at that already, which I wasn't, let me just reload this. Yeah, so we got this message that said everything's great. And then we go over to the console and it says, hey, whatever you were trying to do there in JavaScript by appending that thing to the DOM, that was not going to work for you. So it was trying to take this markup, turn it into the inner HTML of a div and drop that onto the document. So if that sounds terrible to you, it's that hunch is probably correct. Like, I don't think that's a production ready kind of an approach to it. So let's go look at that really quick. Oh, too many tabs. JavaScript. All right. So this is where it's logging that payload that happens right here. And then it's trying to create a div element, set the inner HTML to the payload, and then append the child. Anything obviously wrong with this that you can see? I wonder if I just console.log that element, what's going to happen? I've got a div. It's got a TurboStream with an action and a target, a template inside there, template content. Hey, look at that. That's a custom web element right there. The template content must be like a slot or something in whatever that terminology is that I don't know that well. And then I get this operation would yield an incorrect node tree. Maybe there's something that's not a div that's supposed to wrap these things.
Are you still live?
I think we're still live. Are we still live? Yeah, we're still live.
Yep. Well, I'm not gonna interrupt.
All right. So I do wish that I had an example of a working one so that I could go back and reference that. It's a TurboStream's message is a fragment of HTML consisting of TurboStream elements. Every TurboStream element must wrap its included HTML inside a template. I'm assuming that's kind of where that, I definitely did not have that right before. We're already doing the reusing of the server-side content. Okay. I'm not really sure. Is document the right thing? So maybe it's document.body.
Yeah, that's it.
Did that work? I think that worked. It was just trying to put it in the wrong place. Okay, so let's try this. We're going to say, you know what, the products inventory is 10 now. And we're going to say, here's the new product inventory. Look at that. Boom, it worked. It just tried to put it on the document instead of the document.body. Okay. So that's kind of the thing that I thought was fairly novel. I hadn't seen anybody talking about it, and there was just this one random, I'm not even going to be able to find that, but there was a tweet by DHH like a year ago, maybe at this point, that was like, people were asking him, how the heck does any of this stuff work? And I don't think the documentation was quite there. And he said, fun fact, little known, you can just take TurboStream stuff, put it into the DOM and it'll process. And that sounded so crazy that we had to try it in one of the Ruby brigades. So that's kind of the demonstration of it, is if you can get that stuff over a WebSocket or somewhere and get it to the point where you can render that in the page, or pin that as an element on the page, then it will just process. And you kind of saw that happen, right? So let's change it to like 100, and you can kind of see it all happen live. Oop. All right, let's reload it. I love this message. It says module specifier application does not start with. It's all red and scary, and then the thing right below it is green and says it's polyfilled, you can ignore it. Which reminds me of everything that ever happened to me as a kid. When I would like do something that hurt my sister, she would go and tattle on me, and then I'd be right behind her like, don't listen to her, everything is okay, nothing actually happened. That's what this feels like, is there's a big red error and then there's something right behind it. It's like, no, everything's cool, nothing happened. All right, so I'm gonna change the inventory on this product to 100. And I'm also gonna bring up the network and see the cable come in as well. All right, so there's that. All right, so you can see it was pretty quick. It updated to 100 in stock, enabled the button for me, and then you can see that the message kind of came through and got printed out. And if I go back and change that to 0, then it drops back and becomes out of stock. That's the kind of like event-driven stuff that I think is going to be really interesting and compelling in Rails as hotwire gets more traction. Cool. All right, I think I'm done. It worked. I was hoping that it would. Thank you, everybody, for joining remotely. I'm going to push this stuff up to a repo so you can all glare at the code and poke holes at all the terrible things that I did to make it work. And maybe we can improve it in a future one. Maybe we can replace it with the official stuff that's now documented. That would be pretty neat. Cool. Thank you. Happy November Rails meetup. We'll be back next month, I'm pretty sure.
Thanks, Tim.
Yep.
Yeah, well done.
Thank you.
Yeah.